Hi, welcome back to LeetCode. So today I'm going to discuss LeetCode problem 1310 XOR queries of a Subarray. So the problem is that you are given an array of positive integers. You are also given the array queries where queries I contain left I and right I. So for each query I, compute the XOR of elements from left I position to right I. That is array left I XOR array left I plus 1, then then XOR of the array right I. Return an array of answer where answer I is the answer of the ith query. Suppose for this example 1. So this is actually an array and this is actually query array. Okay, so I have written actually and this answer actually array. So what actually content? So just go to the explanation. So array is actually 1 3 4 8 and first queries is actually 0 1, right? So this actually left and this is right. So I have to find out that answer of 0, it will contain the XOR value of array of 0 XOR of array of 1. Okay, so actually 1 XOR 3, this is the actually answer. So 1 XOR 3 answer is 2, so that's why answer 0, it will contain actually 0. Okay, then answer 1 means query 1, it actually 1 to 2. So the answer 1, it will contain what? Array of 1 XOR of array of 2. So array of 1 value is 3 and array of 2 value is 4, right? So what is the XOR value? Then XOR value is actually 7. So that's why answer 1 actually contain 7. Okay, similarly for query 2, the position actually is 0 3 0 3. So our answer 2, what will contain? Array of 0 because left position is starting from 0, then position is array of 1, then array of 2, then XOR of array of 3. Got it? So this actually 0 is content 1 XOR 3 XOR 4 XOR 8. Okay, this is actually the answer. This actually give us what value? You can check actually XOR value will be the 14. Okay, so I will store this. So what actually you are doing actually here actually? So for each, I am actually traversing the query array. Okay, brute force approach. First think about the brute force approach. So I am traversing the queries array. I will get a pair which will, what it will contain? It will contain a left and right, left position and the rightmost position. Then from that position to rightmost position, I actually traverse this array. Okay, and I will find out what is the XOR value. Okay, so like first I will traversing starting from L, suppose 1 to 2. So L actually 1, R is equal to 2. Okay, so I will take a for loop. So 1, I will current value is 0. Then I will traversing this from L is equal to 1 to I is equal to L, then I less than equal to R. So then its value is 3, then it will get to the 4. Ultimately whatever the value it will what is the value in the current, that will I will push into the answer vector, right? For each query I have to do that. So I am traversing that L to R for each time, for each query. So what is time loss to this for brute force approach? You understood the brute force approach, right? What we are doing? For each query, I will get left and right, left position, the right position. Then I am traversing the array vector from that position, from left position to right position for particular that query. And I will take the XOR value. So what a time loss to this? Suppose there is Q query, number of Q queries. Then for each query, I am traversing the array to get the XOR value. So time loss will be number of, for each query, I am traversing suppose L length of the array. Suppose average length is L. So time loss will be Q into L. Understood, right? So this is you can check what is the constant. Constant is that array length and queries length can go up to maximum 10 to the 4. So if I assume that number of queries actually 10 to the 4 and length actually traverse, because array length can be 10 to the 4. So for length can be I think 10 to the 4. So it will be actually 10 to the power 8. So it will actually exceed the it will actually give us TLE, time limit exceeds. So we have to think about the optimized approach. How? Here actually you can check actually one XOR properties actually. What is the XOR properties? Suppose our array is look like this: A, B, C, D, E. Suppose this is actually our an array, and suppose query is suppose 2 to 4. This is 0, 1, 2, 3, 4. Okay, 2 to 4 means what actually ultimately for iterative brute force approach, what do you think? We start from this and end till this. So we will actually particularly find out this XOR value C, XOR D, C, XOR E, right? So this is ultimately we want to find out what is the value of this. Now suppose we already calculated the value of A XOR B, XOR C, XOR D, XOR E. Okay. Now somehow if we XOR again this A XOR B, this actually ultimately stored in the 4th position, and again we are XORing the value of A XOR B, A XOR B. Okay. So what is the XOR properties? XOR property says that A XOR A or X XOR X, the value is actually 0. Okay. For same, if we take the two same value and we find out the XOR value, then it will give us 0. Okay. So how I am using this, you can actually think about this. Like we already stored the XOR value from 0 index to 4th index. Okay. That is actually ultimately A XOR B, XOR C, XOR D, XOR E. Now, what about if we subtract the remaining or the extra XOR value, like this is actually extra because our range is actually C to E. This is our range. This is our range, right? And this is actually extra. This is actually extra. So extra, but if we do XOR again with our current XOR value, then you can check what we will get. So this actually is this actually whole XOR value. This is actually the whole XOR from A to E, right? From 0 position to 4th. Now what is the extra? Extra is 0 to 1. So if we subtract this XOR value, then we will get the XOR value. How? This actually the whole XOR value, this whole array from 0 to 4, and this is the extra XOR value is A XOR B. A XOR B, this extra. If we XOR this, what we will get? This A will cut, because this is ultimately like if we pair up also, you can actually pair up also, like A XOR A, then XOR B XOR B, then XOR C XOR D XOR E. So it will give us actually 0. This also give 0. So ultimately the answer will be C XOR D XOR E. Ultimately we want to this actually the value. Understood, right? How actually what is the properties currently? So if we we will get any L or R randomly from the queries array. So first of all, find the XOR value of R position. This is actually the contain the XOR value of from 0 to R, right? From 0 to R, whole array. Suppose any array, this is actually the whole array, and this is actually range from L to R. Okay. Suppose we find out what is the value of the XOR array for this will actually return that, like from 0 to R, from 0 position to R. Okay. First of all, find out this. Then check what is the XOR value of the L minus 1. That will return actually 0 to L minus 1 position. That is the extra array we have in the before at the front. This is really extra. This is an extra array. So if we just XOR this value, XOR of L minus 1, then XOR of R, this will actually return our answer of particular XOR value of the, it will return actually XOR value of the particular L to R, right? It is clear. So I think all you have understood the logic. So if you understood the logic, And if you can try the code, actually it will be easy then. Like I have already explained what is actually doing, so you can just implement this, and then you can actually come to this the code part. Okay, so, and if you like the explanation, please like the video, and if you not yet subscribed to the channel, please subscribe the channel. Okay, now what actually doing, you already understood. So what are you doing? First of all, store the from 0 to all r the XOR value from 0 to r. Okay, then randomly I am actually iterating the queries vector where I will get L and R. So for each R position, I will find out what is the XOR value of the from 0 to that R, and I will find out what is the XOR value of from 0 to L minus 1. Then I will just XOR these two value, then I will get the XOR value of L to R. So this is what I will do, L minus 1. Just before we are starting, suppose we got one query from 0 to R, suppose 0 to R. Then if I do what, XOR value of 0 to R, this will return one thing from 0 to whole array, whole XOR value. Then I am what is doing, XOR value of 0 to 0 minus 1, because here left is, because here actually left is 0. So what I will do, here actually doesn't exist, 0 minus 1 means minus 1 doesn't exist, no index is there. So that time what is the, from for particular one situation like 0 to R, where left is already 0, that time I do not have to do, there is no front, there is no extra array at the front of this particular array, because this is starting from 0. So that time I do not have to subtract this, or I do not have to calculate this XOR value of the front, because there is no front at the array at the front. Got it? Understood? So just go to the code now. So first of all, taken an XOR vector, which actually I am calculating for 0 to I, particularly the XOR value from 0 to I, particularly any index. Okay, and size will be the same, array size, because if the array length is n, that time our XOR 0 to n, I can actually calculate the XOR value, right? And XOR value 0 at index, it will be array of 0, because only one element I have seen till 0 to 0. Got it? Now we come to 1. That's why I am studying for loop. I is equal to 1, I less than array size, I plus plus. I am doing what? XOR of I is equal to array of I, current index value, and the XOR value of the previous. So I am taking the XOR value of 0 to I minus 1, then XOR value of array of I. Understood? This is what actually I am saying. Previously XOR value till I minus 1, it will be stored in the previous index, XOR value of I minus 1, right? Then calculate the XOR value of with the current element the array of I. Then it will store into the XOR value of I, because I am storing the XOR value from 0 to I, right? So I have already calculated XOR value of 0 to I minus 1. So just take the XOR value with the current array element or array value. It will actually give us the XOR value of 0 to I. Got it? In this actually I have actually taken a calculated vector. Okay. Now I have to return a vector of answer that actually return is for each query what is the XOR value. So that's why I have taken a vector of answer, vector of integer answer, and I am just traversing each queries. I will get a left and right. For each query there will be left and right, left position and the rightmost position. So if left is equal to 0, I have already said for left there is no array at the front for the whole array. Whatever the 0 to R, this is actually the perfect. I don't have to calculate the extra, I don't have to adjust the XOR value. So if left is equal to 0, that means just answer dot push back the XOR value of the particular index R from the XOR array. I have already calculated 0 to I. So that particular index R, I will return that value, I will insert that value into our answer vector. Else, what actually the situation, like this actually the whole XOR vector where I have calculated, suppose I want to calculate the value of this L to R, L not equal to 0, that time it will come here, and I have to adjust this front array, because this is actually extra. I know what is the XOR value of 0 to R. This I know XOR of R, I will get that, but I have to, but this is actually extra. So that time XOR this with the XOR of what is the, this is a whole array vector, whole array XOR value, this XOR of R, and take the XOR value again with the XOR value of L-1 index. This is actually the leftmost, and just previous index it will take the XOR value. I have already shared what is the properties of XOR, and it will give us the particular this XOR value of this, particularly L to R. Got it? In this actually just put that value into our answer vector, and at the end, after completing each query, return the answer vector. So here actually we are not iterating input array every time for each query. In suppose we are actually doing that, right? For each left position, I will start iterating till I go to the right R position, and I'll take the what is the XOR value and put that into the answer vector. So here actually you can check constant time where it's just checking the value. Just go to that index value, particular index value. So that time it's constant time big of 1 for each query. I'm actually just go to that particular index and take the value. This is efficient. So for each query I'm just taking constant time, so q into 1. So time will be big of q, number of queries. This is a time complexity. And space complexity. We are taking an extra XOR vector that are actually calculating the XOR value from 0 to I. So that time complexity, space complexity will be big of n, and time complexity was big of number of queries. Got it? Understood the logic? Still you have any doubt, you can actually comment. I will definitely help. Thank you.